Today we are going to learn about NumPy Reshape, advanced techniques for data scientists. We will explore advanced reshaping strategies to enhance data manipulation skills crucial for optimizing workflows and model performance. Welcome to our session on NumPy Reshape, advanced techniques for data scientists. In this video, we'll delve into the importance of data reshaping and how NumPy's powerful capabilities can be leveraged to optimize data science workflows. Reshaping is not just about altering the structure of data, it's about enhancing efficiency in data manipulation, which is crucial for model performance. Throughout this session, we'll explore a range of advanced techniques that go beyond basic reshaping, providing you with the skills to handle complex datasets effectively. Our goal is to equip you with the knowledge to apply these strategies in real-world data science projects, ensuring your models are both efficient and effective.
Multidimensional arrays are a cornerstone of data manipulation in NumPy. They allow us to organize data in multiple dimensions, providing a flexible way to handle complex datasets. Understanding how these arrays work is fundamental to mastering reshaping. In essence, a multidimensional array is an array of arrays, which enables us to work with data in a more structured manner. Consider a simple 2D array, which can be visualized as a matrix with rows and columns. Now, think of extending this concept to 3 or more dimensions, which can be particularly useful in scenarios such as image processing or 3D data modeling. The key advantage of multidimensional arrays lies in their ability to represent higher dimensional data efficiently, minimizing the need for nested loops and complex data structures. However, working with these arrays requires careful consideration of dimensions and shapes, ensuring that operations align correctly to avoid errors. Mastering multidimensional arrays will significantly enhance your data manipulation capabilities, paving the way for more advanced reshaping techniques.
Dynamic reshaping is a powerful feature in NumPy that allows for flexible data transformation. This technique is particularly useful when you're dealing with datasets where the exact dimensions are not known in advance. By using the -1 parameter in the reshape function, NumPy can automatically calculate the appropriate dimension size based on the existing data. For instance, if you have a flattened array with 12 elements, you can reshape it into a 2D array with 3 rows by simply specifying -1 for the columns, and NumPy will handle the rest. This flexibility is invaluable in data science projects, where datasets can originate from various sources with differing structures. However, it's essential to ensure that the total number of elements remains consistent during reshaping, as discrepancies can lead to errors. By harnessing dynamic reshaping, you can streamline your data transformation processes, making them more adaptable to changing datasets and improving overall workflow efficiency. Integrating NumPy's reshaping capabilities with pandas can significantly enhance data analysis tasks. Pandas, a powerful data manipulation library, often works hand-in-hand with NumPy to provide a comprehensive data analysis toolset. By reshaping data in NumPy before importing it into pandas, you can ensure that your data is in the optimal format for analysis. This integration is particularly beneficial when handling large datasets, as NumPy's efficient reshaping can lead to faster processing times in pandas. Consider a scenario where you have a large dataset stored as a NumPy array, and you need to perform a series of data analyses. By first reshaping the data into a more manageable format, you can leverage pandas' data frame operations more effectively. This approach also allows for easier integration with other data analysis tools and libraries, providing a seamless workflow from data transformation to analysis. To maximize the benefits of this integration, it's crucial to understand the unique strengths of both libraries and how they can complement each other in a data science project.
Reshaping high-dimensional data presents unique challenges that require careful consideration and planning. One of the primary obstacles is maintaining dimensional consistency across different operations, ensuring that each reshaping step aligns with the overall data structure. High-dimensional reshaping can also lead to increased computational complexity, necessitating efficient algorithms and functions to manage the data effectively. In real-world applications, such as image processing or neural network training, high-dimensional reshaping is often required to prepare data for analysis or model input. To address these challenges, NumPy provides a range of tools and functions designed to streamline the reshaping process, including functions that help verify shape compatibility and optimize memory usage. Additionally, understanding the underlying data structure and planning your reshaping strategy can prevent common pitfalls, such as mismatched dimensions or excessive computational overhead. By mastering these techniques, you can handle high-dimensional data reshaping with confidence, ensuring that your data science projects remain efficient and effective.
Reshaping large datasets can have significant performance impacts, making it essential to optimize these operations for efficiency. The size and complexity of the data can lead to increased processing times and memory usage, potentially affecting the overall performance of your data science projects. To mitigate these impacts, it's crucial to understand the underlying mechanisms of reshaping and how to apply them effectively. One strategy is to minimize unnecessary reshaping steps, focusing only on transformations that are essential for your analysis or model. Additionally, using efficient data structures and leveraging NumPy's optimized functions can help reduce computation time and resource consumption. In real-world scenarios, such as processing large-scale datasets for machine learning, optimizing reshaping operations can make a significant difference in model training times and performance. By balancing speed and accuracy, you can ensure that your reshaping processes are both effective and efficient, ultimately enhancing the overall workflow of your data science projects. Automation is a key component of modern data science workflows, and leveraging NumPy's Reshape function can significantly enhance data transformation automation. By automating reshaping processes, you can streamline data preparation tasks, reduce manual intervention, and ensure consistent results across different datasets. Building reusable reshaping functions is an effective way to achieve automation, allowing you to apply the same transformations to various datasets with minimal effort. These functions can be integrated into larger data pipelines, providing a seamless flow from data ingestion to analysis. For example, consider a scenario where you need to prepare a large dataset for a machine learning model. By automating the reshaping process, you can quickly adapt the data to the required input format, saving time and resources. This approach also ensures that your data transformations are consistent and reliable, reducing the risk of errors and improving the overall quality of your data science projects. By mastering automated reshaping techniques, you can enhance the efficiency and effectiveness of your data workflows, ultimately leading to more successful outcomes.
The real-world applications of NumPy's reshaping capabilities are vast and varied, playing a critical role in many data science projects. Advanced reshaping techniques enable data scientists to efficiently prepare and manipulate datasets, ensuring they are in the optimal format for analysis or model input. From image processing to natural language processing, reshaping is a crucial step in many data science workflows. For example, in machine learning projects, reshaping can be used to format input data for neural networks, allowing models to process images, text, or other complex data types effectively. In another case, reshaping might be employed to aggregate and analyze time series data, providing insights into trends and patterns. The benefits of advanced reshaping extend beyond individual projects, contributing to the overall efficiency and effectiveness of data science workflows. As data science continues to evolve, new reshaping techniques and tools are emerging, offering even greater flexibility and performance. By staying informed about these trends and mastering advanced reshaping strategies, data scientists can ensure they remain at the forefront of this dynamic field. As we conclude our session on NumPy Reshape, Advanced Techniques for Data Scientists, let's recap the key points we've covered. Mastering advanced reshaping techniques is essential for optimizing data manipulation in data science projects. By understanding and applying these strategies, you can enhance your data workflows, improve model performance, and ultimately achieve greater success in your projects. The impact of reshaping extends beyond individual tasks, contributing to the overall efficiency and effectiveness of your data science endeavors. We encourage you to continue exploring and learning about NumPy's reshaping capabilities, staying informed about new developments and trends in the field. By doing so, you'll be well equipped to tackle the challenges and opportunities that lie ahead in the ever-evolving world of data science. Thank you for joining us, and we look forward to seeing how you apply these techniques in your future projects.